Καλώς ήρθατε και πάλι. Σε αυτό το session θα μιλήσουμε για το AI και πώς αυτό συναντιέται με τη τεχνολογία των ημιαγωγών, AI meets Silicon. And again, we have the honor of having one of my dear colleagues here in Athens from Ansys, Mr. Jerome Toublanc, which will go first with his part of the presentation. So a few words about him. Jerome is currently part of the Ansys product management team, where he focuses on cross-product solutions for electronics, semiconductors, and optics, emphasizing the development of advanced multiphysics simulation flows. But most of all, he's a charismatic storyteller, and he can really transform very complex and nuanced ideas to stories that everybody, any audience can understand. And this is what he will do here today.
Bonjour, everyone. So we're waiting for the slides, I guess. We'll start. Here we go. So thank you for being here. I hope you did enjoy the lunch. Now we will talk a little bit about how AI meets silicon. It's a very exciting topic, at least for me, because AI, it's in my everyday, I would say. We try to incorporate AI in many new solutions. But what does it mean? What's the meaning for most of the people? It could have different meanings, so I will give you one of them, and my peer will explain another angle later on. But let's have an understanding of what is silicon first. So I like to explain a little bit where the innovation from the semiconductor is coming from. And there are actually three different pillars, at least three different topics we can classify in three different pillars. First thing first, why do we have semiconductors? Why do we have to make new semiconductors? It's because of the consumers. It's because of the market. Chips are everywhere. As you know, for the mobile, for Internet of Things, for automotive, we do have a lot of components every year, everywhere to make. And since few years, we talk a lot about AI. So first statement, there is no AI without chip. So even when you hear about AI, it means behind the scene, you do need a very sophisticated semiconductor that is able to compute a lot of information in a very short amount of time. So it's very powerful. We consume a lot of power. It's a lot of energy, but the outcome of this technology brings a lot of value for many industries. Until recently, people were mostly focusing about AI as data center. It's something on the cloud. It's requiring heavy computing. But over the time, because of the promises of this technology, people want to bring AI closer to the market. So now we start to hear about AI at the edge. So what does it mean? It means we will change the existing semiconductors. We will change the existing chip and make them more clever. We will incorporate some AI technology inside. But again, what does it mean? It means new software to drive those new components, but new hardware. So it means AI is calling for new semiconductors. So how does AI then help for the innovation of these new semiconductors? That goes to the second pillar. It's the technology. This technology is coming from the foundries. So usually big AI, big chip dedicated to AI are typically using the very last advanced technology where we have very tiny transistors. We talk about chip with billions of transistors, with millions of interconnects. Those chips are very complex. But when we talk about AI at the edge or chips with embedded AI, we talk about chips with maybe less mature technology, but a specific component, a specific block or specific part inside the chip that will be dedicated to AI. And that part will be new for this semiconductor because it's consuming, as I said, a lot of power. This part of the chip will have to compute, make a lot of computation. So that brings new challenges from a technology point of view. How do we optimize the power? How do we dissipate the power? A lot of innovations from the technology point of view to make that possible. On top, semiconductors evolve. So here I'm talking about single die chip, but now we start to see multi-die chip or chiplet. This is potentially some buzzword you heard already about. This is also following the track. Thanks to this new technology where we can mix different components inside the same chip, it means you can have one component dedicated to AI. So what does it mean? You can easily incorporate this AI technology in your semiconductor component. But again, that brings a lot of challenge because this additional chiplet will compute a lot of power, a lot of energy. So it means Foundry will use AI to find out new material, to find out new manufacturing process, to make sure the technology is optimum for those new embedded AI requirements. But that brings us to the last pillars. This is technology. This is where foundries are helping us to get the best material ever. But then you need engineers. You need designers to design a component. They will try to maximize, indeed, this new technology they have access to make sure they can make an application dedicated to the market. So here, don't get it wrong. Making a chip is very complex. Sometimes people have this picture. It's one guy who will be in charge of a chip. But in fact, it's a team of guys. It's a lot of experts behind the scene that has to make the design. And the fact you bring AI, you only increase the complexity. You bring new experts, you bring new people into the game to make those components possible. So it's becoming a real challenge for those designers, and they have to think about a different way to be able to deliver this new AI product. So this team will rely on tools, and this is company like Ansys we belong to, where we will propose a lot of tools. And this is where also from our side, we will have to make those tools evolve. We have to use also AI technology embedded in our software to be able to tackle these new emerging constraints. One of the severe constraints because of AI, this is why Ansys, we are part of the game, it's mostly a matter of power and thermal. How do you handle this new extra power consumption? How do you handle the dissipation of this power through the temperature? So here it's what we call a pure multi-physics challenge that this team have to take into account during the physical implementation flow. So a lot of new workflow between different engineers that has to be considered. And without AI technology, it's almost impossible today. So this is why AI is requiring new chips, but Foundry try to use AI to make this technology optimum for these new chips, but also engineers will use AI to make sure they can design those chips. So sometimes it's not necessarily obvious for people to understand how AI is used. Just think about the chip architect who have to make the right decision for this new component. I was talking about this chiplet design where you have a lot of chip inside the component. It's very complex. Why do they do that? First, it's to address the market, to be able to compute a lot of power. But of course, they have constraints, the cost, and they have the multi-physics constraints. No black magic. If you consume a lot, if you compute a lot of information, it's a lot of energy, it's a lot of heat you have to anticipate and manage. So this is why without AI, since each of the constraints and target can interact with each other, and since you have contradictory answer to each of those topics, it's becoming almost impossible without AI technology. And this is all the idea of AI technology. It's to be able to pinpoint very quickly what is the best trade-off for my design, where I can satisfy my expected performance within the cost I'm looking for, and having into perfect control the multi-physics phenomenon. That's another example to show you how power thermal is also very important for people. As I said, even if they use the last technology from foundries, where we will dissipate in the best manner this energy, still they have to perfectly sure they do manage the power consumption. Because as you know, AI is very angry. So here, more and more people want to understand what's the relationship between power and thermal, and this is a topic they might not know. So they spend time to use AI to create what we call a meta model. And out of this meta model, they can have a direct understanding of, depending on the way they do manage the power consumption between the different die, they will directly see how hot can become this component. And then they know if it's really physically implementable or not. So AI is helping to better understand different physics, to better understand different constraints in a very interactive manner. And thanks to that, chip designers can focus on innovations. Instead of fighting against all those constraints, they can really focus on how can I innovate? How can I think in a new manner to address this specific new product? As a proof of importance, AI is also creating a lot of partnership because no one can tackle this topic on its own. So recently, we announced a partnership with NVIDIA. NVIDIA is very well known to propose some hardware environment to help people to understand where they go. So we can build digital twins of your product. We can better anticipate your 6G network in real life, again, using AI technology. But we're fully aware that this technology will still increase the demand for more power, will still increase the demand for more hungry components. So we use this same partnership to also make some research in that area. How can we make sure the new generation of engineers can optimize the available technology today to make sure there is no power thermal issue, no matter how much AI people will implement in their component? So that's, I think, a way to think about AI. So the key message, the key question was how AI meets silicon. Actually, one feeds each other. And today, one needs each other. The more people will use AI, the more new generation of semiconductor people will need. And this new generation of semiconductor will need AI to be able to be addressed as expected. So I hope it's giving you an idea of relationship between AI and semiconductor. Thank you.
Thank you very much, Jerome. Merci. So next we will have Mr. George Flamis talk about Renesas products and how AI contributes to the development and to the overall user experience of the products. George holds the position of Senior Engineering Manager in Renesas Electronics. He's leading the AI solutions team that develops applications for AI/ML technology. Of AI/ML technology, sorry, and supports business acceleration in MCUs and MPU devices. So let's welcome George and hear how AI contributes to products that we may use every day in our lives.
Thank you for the nice introduction, and thanks everyone for being here, listening my talk. And really, before continuing in English, I wanna mention something that Manojis, the president of HETIA, said at the beginning. Said that we need in Greece a big national company, μια πολυεθνική, that will be able to contribute on whatever we do in this area. And indeed, Renesas is on that part. Having said that, let me mention that new age AI-powered applications are becoming increasingly important in our daily life, and that is what we really see on that part. And we have seen people talking about it over the time. What is needed and what are the challenges for achieving that is definitely high performance for complex computer tasks. And hopefully Jerome's talk just earlier explained how we can make that. Ensuring that the cost will remain an effective area and seamless integration will exist in the infrastructure. And at the same time, maintaining robust security and privacy is a lot important. I heard earlier Mr. Grandman mentioning about the Moore law and where that law ends. That comes together with Dennard scaling on the way that we're making the devices. However, this is overall an increase and move forward, and new technologies, new architectures on making silicon becoming. They get assisted by AI, but the main purpose is indeed to do the AI in a way that all this functionality is met. Having said that, let me move to my first slide, where what we do at Renesas is that we really want to protect the training data, add the data labels as needed, and avoid unauthorized access, prevent data be poisoned by whatever comes and what can do that, comply with privacy and copyright laws, and ensure that data sharing and exchange that. How do we do that? We do that with the 3 pillars that you see there over where we can create really tiny models that can execute on the device. They don't have to rely on connecting to the cloud, meaning that we don't have to connect and exchange data with another medium. And in that way, we are not exchanging data, we're not losing the data, or we're not being in risk of our data to be poisoned. Having said that, on the part of the 3 different areas. Let me start first with real-time analytics, where data are collected from sensors, and we do provide Renesas Reality AI system as an end-to-end framework where we can capture the data and bring them on the silicon for execution together with a trained model. And that is overall an end-to-end process that runs seamlessly inside our tools, of course, with consultants and customers, and that helps to reduce the time to market. On the voice part, however, voice is also a pretty important area of AI, where voice commands, language models, and recognition of sound effects are becoming crucial. So we have 10 key enablers on voice user interfaces that comes together with audio front-end modules that assist in terms of signal processing to make the system even more robust. And last but not least, on the vision part, usually that is where we do see AI a lot important. There is where most of the computational resources are consumed doing vision, exactly because the data are quite large. And we do offer a number of application examples to accelerate time to market to customers, and that again runs really on the device without connection and remain on the part of what we would say tiny ML applications. A bit detailed on that part. Overall, usually just 5% of the typical tiny ML applications, and the analytics is the time that we cost on collecting data and those that are really useful by the model. Having said that, the infrastructure that we built is a seamless system that starts from a regular IDE environment, like those that embedded software can be developed for the devices. In there, specific plugins will help communicate to the device and collect the data. The data will be given on the next level of the tools. The tools will analyze the data, and the engineer will be able to work further on the understanding and analyzing the data, wherever those are useful or not useful. What can we do with that? Once this is finished, the model can be trained and then deployed on the device exactly by the same tool. It's just one tool that is used for all this process. A few parts that, a few ideas, a few solutions that we have on our end is those that are shown here, where you can see the problems on arc fault, security interrupter is pretty common thing to happen also in photovoltaics plants. HVAC conditioning monitoring also resolves problems on the operation of those expensive devices, and even at home where roller floors, vacuum cleaners, they are able to tell what kind of floor is underneath and control the speed of the operation, and that brings more on the user experience, on how the quality of the device can help the end user to enjoy the benefits and the features of the devices they have bought. On the voice, this time we do offer, of course, hardware in terms of reference kits that are specifically made for voice. Why? Because they need microphones, they need specific infrastructures and arrays of audio sensors to collect the data. We do have a development environment that really relies on a text-to-model operation, meaning that the model, the training model underneath is on a way of in a way of understanding the syllabes of the language, and through that recognize the phonemes. The phonemes will build the words that need to be recognized without having really to collect actual data out of the device. And that helps us to have more than 44 languages, and also to support simple applications like the voice commands recognition, but even more demanding applications like natural language understanding that approximates the way that the customer, that the user, the human talks, so even becomes more effective on the way of recognition. Again, I'm saying that I want to mention numbers here. We're talking about processors running with a single core at maybe 400 megahertz, which is pretty small device, and that in the same time reduce the power consumption of running this kind of applications. And that comes together with other features like voice anti-spoofing, like audio front end, where noise can be removed from the speech, speaker ID, and other applications that are available. In terms of use cases, voice control for wall switch is a kind of common application. I think that we have seen that becoming more and more popular at homes and buildings. Voice commands with anti-spoof, meaning that the device will understand when there's a recorded command by a phone or by something else. I mean that someone at home cannot turn on the kitchen by some recording, and those can be the kids. That the kids are very smart now on a way of controlling our devices. And of course, natural language understanding, approximating the way that natural human speaking happens, and that happens in MCU-based devices, and we make it work on the advanced systems that we're providing. So on the vision part, there is where, as I said at the beginning, more computational power is needed. The data become huge. We're moving from our single core MCUs to dual or multiple core MPUs, where we also have the ability to have reconfigurable hardware on that, and together with the tools that we're providing, even an AI model can be designed to be executed on the hardware. That comes again together with a number of application examples like personal access system. It does voice recognition, face control, and at the same time anti-spoof of vision anti-spoof, meaning that a picture won't be recognized for that. And overall, that comes together with a large ecosystem of partners that we have, where they assist us with the development of those devices. Somewhere here, then let me go to the conclusion in terms of AI and the IoT. Obviously, the convergence of them is a mega trend. Although sometimes people think that AI is another new industry, which is not the way that we see it at Renesas, and because this is a view that is limiting and is missing a key point. The key point is that it's not just an industry, it's not just a new technology. In fact, it is a convergence or a tipping point which is making and giving the ability to the industry, to the applications, to the experience, to enlarge further, to become even bigger. And in that way, with the systems that we develop in Renesas, we'll make that happen. Thank you very much.